Hi everyone, I'm Chua from AvidThink, a research and analysis firm covering infrastructure technologies. And I'm back again for a chat with RaviKiran Gopalan, CTO and co-founder at Aira Technologies, a startup attempting to bring AI and machine learning to wireless networks. If you haven't yet watched our first chat and interview, you should do so. Ravi did an excellent demo, and the link to that initial conversation is in the description below. In any case, I'm back with Ravi, and we have a chance now to get caught up on the latest with Aira and with RANGPT. We'll see how AI, ML, and generative AI or GenAI can be applied to RAN for multiple use cases. With that, let's get started. All right, I'm going to turn it over to Ravi. Welcome, Ravi. Go ahead.
Roy, I want to introduce you to Aira a little bit more, give you a little bit of an update on RANGPT, talk about a couple of new features, how we are evolving the platform. But before that, let me give a little bit of an introduction to the company itself. Aira, we are all about using machine learning and a data-driven approach to design, deploy, and manage wireless networks. And that's what we are all about. And as a company, we have been around since 2020. We got started in 2019, but we have been kind of up and running since 2020. The founders are myself. I'm RaviKiran Gopalan. I'm the CTO of the company, and the CEO of the company is Anand Chandrasekhar. I've had a background in wireless through and through, and a couple of decades in the industry before getting to Aira. And Anand has been in the leadership positions of various companies like Intel and Qualcomm before getting to Aira. But it's a company made up of seasoned experts. We have about 2/3 of the company have PhDs. 2/3 of the company, once again, are from companies like Qualcomm. So it's a seasoned group of people trying to achieve this vision. And what we are about is, again, improving the efficiency in multiple dimensions for the operators. If you look at our products, we talk about it in 3 layers. At the lowest layer, we are using a machine learning based approach to improve spectral efficiency of networks. We call that product line the beam management suite. At the next layer up, we use machine learning to control the state of the network and manage the network in a more intelligent way and improve the energy efficiency of the network by doing so. That product suite, we call it the energy management suite. And then the last suite, which is the highest layer, is where we are trying to improve the operational efficiency of the network. This is our GenAI product, RANGPT. We'll be talking about that a little bit more in detail today. And essentially, this is Aira's attempt at making GenAI more accessible to telcos and helping them resolve incidents, detect anomalies, and write automations in a much quicker manner than they are able to do it today. Okay, the unifying philosophy behind all of these is that we use a data-driven approach. We generate insights based on existing data that's flowing through the networks, and these insights allow us to do all of these things, do better spectral efficiency, better energy management, and better operational efficiency in a smarter manner. And we've been showcasing these product lines for a couple of years now. Last MWC, we showcased our RANGPT product line at Tech Mahindra's booth as well as VMware's booth. We showcased our spectral efficiency product line at the Dell booth, and we are in the process of doing a couple of different POCs with customers for both of these technologies. MWC of 23, we showcased our energy management suite as well as our spectral efficiency suite. So, and we expect to be showcasing more of the same in 2025 and other events before that as well. Okay, so the purpose of this meeting today was to dig a little bit deeper on RANGPT and showcase some of the newer features and have a discussion around how we think about this platform and how we think operators will be using it. So let's get into that. So as an architecture goes, we are really designing RANGPT as a split architecture. There is a software module, which is what the user and the operator will interface with. This will be a standard software module. It will have an LLM component to it. It could be either an LLM that's inbuilt and built into the software module, which will be our own LLM, or if the operator has already chosen their favorite LLM, let's say it's GPT-4 or something else, and they have an API access to that LLM, they could be using that LLM as well. So we have both options available for the operator, and this software module interfaces with the network via the SMO or SON. Wherever there's an edge compute platform that has access to northbound data coming out of the network, we insert a small application into that. So if it's a SMO, for example, we have a gateway RAP that we put on top of the SMO. This RAP is how the software module, the RANGPT software module, gets access to the data. And if there is automations and if there's control that we want to do of the network from the software, the RANGPT, the RAP, gateway RAP is able to translate commands using standard O1 or standard EMS, NMS kind of APIs to control network elements. So that's what I mean by it's a split architecture. There's software and RAP. And as far as the user is concerned, all they see is a nice GUI, user interface, and depending on the questions they ask, they either get answers or code or plot or automations or apps. So that's the paradigm. That's how we are thinking about this. And we are really thinking about various use cases. It's a platform. Ultimately, the market will decide how operators will end up using this. But in discussions with a few different operators, we have come up with some initial use cases, or you can think of it as pre-packaged use cases that we'd like the operators to start using this platform for. The first one is anomaly detection. We can kind of define observers on the network which are observing certain KPIs, and if they detect certain anomalies or abnormalities, they can alert the operator as to, hey, there's something going on here. And then that leads to an incident management use case where given the alert that, hey, there might be something going on with this site or this particular band, you can use RANGPT to observe that a little bit better, use your existing tools to analyze the KPIs a little bit deeper, and potentially test solutions even. You can control and if you have a fix based on your expertise, you can test your fix directly using RANGPT. We are also thinking that this process of detecting an anomaly and coming up with a fix could potentially be automated for the future. If the same anomaly happens the next time, you don't want to go and do the same fix again and again and again. So the third use case is, can we come up with simple rule-based applications that can be defined and converted into R apps or SON apps, and you can use RANGPT to do that. So 3 different applications and 3 different use cases for using RANGPT as a platform. In our roadmap, we also are working on helping the second part, helping the incident management part a little bit more by coming up with root cause analysis. That's something that's under works right now. That would become another use case for using RANGPT. And like I was saying, each of these use cases have their own workflows. So, and we'll walk you through some of these things and some of the features. So anomaly detection, for example, has a workflow of, hey, what are the KPIs that you want to detect anomalies on? What are the KPIs of importance for you, Mr. Operator? So they can define the KPIs, and they can also define how sensitive you want this anomaly detection to be. What would you consider an anomaly for this particular KPI? So that's what we mean by managing the sensitivity of these detectors. And then once an anomaly gets detected, in the process of managing this incident, there's again a workflow that we have defined. You can observe these KPIs, compare those KPIs with other KPIs in the network, or the same KPIs into the past, do some analysis, and then test solutions. So all of this using RANGPT. And then finally, when you come to generating an app out of this, it's all about defining those objectives clearly. It might either be, today I'm going to walk you through where these objectives can be defined using language, but it could also be objectives defined using a workflow or a flowchart. So it's multimodal. So either way, as long as you define what you want, RANGPT can map that into code, and map that not just to code, but map it into an app, an R app or a SON app, and then integrate it into your SMO. And we'll walk you through that use case as well. Yeah, let's start with anomaly detection. But before we jump into use cases, let me give you a tour of RANGPT, the UI, what are the different aspects of the UI. So this is what you would see immediately. You see kind of a nice simple user interface. There's a command interface. This is where you would ask questions. Then there is what we call an insights tab. So whenever an operator connects RANGPT to their database or to their SMO, RANGPT goes to work, and there are some pre-built, pre-written insights that it starts generating. You don't need to ask the questions. So for example, we plot 3 highest energy consumption consuming sites, plot the top 3 highest energy efficiency sites. So these are standard questions based on our interactions with operators that they are interested in. So you could click on one of these. It'll give you a preview of what this plot will look like, and you could load that as an insight and say, hey, this is what I want to run, and it'll immediately load, and you can dig deeper into this insight as if you asked that question, and you can overlay other things and so on. So that's the insights tabs. We have pre-built questions and plots on energy efficiency. We have pre-built questions and plots on network performance and user experience. Depending on the kind of database that you connected to, these kind of pre-built insights will get loaded automatically. Then there is the dashboard. This is where, as you start interacting with RANGPT and you create plots and so on, and let's say you want to store that plot into your own personalized dashboard, all those plots will appear here. And then this is the app builder that I was talking about, where you can define objectives and generate apps. So that's kind of the overall UI that we want to work through. Let's create a new session here and start with the anomaly detection use case. Like, that's the first one. It starts off by saying, hey, can we detect, is everything okay with the network, or are we detecting something? And some parts of the UI will become clear as I run it. So let me run a simple anomaly detection query. So I'll say run anomaly detection on site S1. So as you know, every network has a bunch of sites. So it's a very broad thing. Detect on site S1 is everything looking okay, and we can define you can define it more clearly and with more resolution. But let's start with something very broad. So it's running. This is something that we have pre-built into RANGPT. So it's running that pre-built anomaly detector, and this is what it's showing. This is based on data that it's already there in the network, in the database. So it's showing, for example, here it's showing the average power consumption of that particular site S1, and also number of users that are connected to the site S1. And it's throwing out a couple of different things. You can see that the the number of users connected to the site has a nice pattern. It's high during the day, it's low during the night, but it's saying that, hey, there's something odd that's going on yesterday night where I am seeing an abnormal behavior. This is different from anomalous behavior because all this is saying is that the energy consumption seems to be like beyond what it should be. But there's a good explanation for that. I see that the number of users have also gone up. So maybe there was an event, maybe there was something else going on, there was a party, maybe there was a music concert. So it's abnormal behavior, it's unusual behavior based on what I've seen previously. But as far as I'm concerned, it's not yet an anomaly. You don't need to be worried about. But then it also is throwing these red dots, and those red dots are alerts. They are saying there's something weird going on. And this I truly think is anomalous behavior because I don't see the number of users for given a particular time of day. It's what it's supposed to be, but the energy consumption seems to be off. So this is something you may want to look at, right? So that's what it's doing. So it's already able to kind of differentiate between unusual behavior, but nothing to be worried about, but also anomalous behavior where this is something you may want to dig deeper into. So that's kind of part one, and if folks are interested, we can dig deeper into that, into this aspect of it. Now,
one question: how does the system determine what an anomaly is? How does it learn over time? Can you guide it or direct it? Can it explain itself? What are your thoughts around that?
Yeah, it can certainly explain itself. You could potentially go and these are all things that we are building into it, where you can click on one of these orange dots and said, hey, why? You could summarize, why did you categorize this as an anomaly? And similarly, you could go and click on one of these red dots and say, hey, why did you categorize this as an abnormality? So it's able to explain its decisions in terms of managing. Let's say it threw out an abnormality and unusual behavior, and next time onwards you want to say, hey, don't show me this next time, I understand this. So you'll be able to kind of manage the sensitivity of the system and manage what it considers an abnormal behavior and what it considers an anomalous behavior, and manage the sensitivity of those things, right? Okay, so the next part is in the workflow, or if you logically think through this, you have used it to detect an anomaly, and you can detect this right now. I've done this on power. You could do this on handoffs. You could do this on some kind of throughput, like total throughput that's being served by a site. So you could run anomaly detection on various aspects of the network. So let's say you've detected an anomaly, then the next use case kicks in, which is now you need to manage this incident. Something is going on. So how do you make that process simple? And this is something that we have already talked about. You could dig deeper into any aspect of the network. So for example, this threw out an anomaly on energy consumption. So I could go ahead and say, hey, I want to know more about the site one's energy consumption. So I can say, for example, plot the energy consumption of site S1 over time, split the consumption into bands, use what is that called, filled area plot. Right. So I can say, hey, I want to know, looks like something going on. Is there something off with one specific band? Is this off with one particular frequency band, or is this across the board something going on? So you're kind of starting to manage the incident. And the first part of managing the incident, if you remember, if you go back to this one, The first part of managing the incident is to observe what's going on. And the nice part is RANGPT will understand what you've asked. It will write the scripts for it. It will run those scripts on the backend database, and it's showing you the plot. It's showing you what this energy consumption is looking like over the last few days. And you can see, and it's splitting it into bands, and you can see that, hey, there's something, all bands are starting to consume more energy. So it's already telling you a little bit about, hey, maybe the antenna was kind of knocked off, or the whole site has been like, maybe there's some other, it's not specific to a specific band, but it's across the band. So it's something that you want to dig deeper into. And that's the next part, which is analysis. And you may have existing tools, either you, meaning an operator, will have existing tools, existing modules to dig deeper into a specific condition or a specific incident that you're trying to manage. And you could do that directly using RANGPT. Like, for example, I could say use ML KPI predictor tool to predict the energy consumption of site S1 over the next, I would say, 6 hours. I want to know, and the main point here is that this here is showing that I can use a tool called ML KPI predictor, which is a tool that we have written, but operator may have other tools, third-party tools or internal tools. And the main goal here is that you can call those tools and not worry about knowing exactly what the API is. How do you present the data? How do you kind of wrangle data and validate and format the data to call this particular tool? All that is taken care of by RANGPT because it's connected to the database. It has, if you look here, we have a place where all the tools exist, like anomaly detection was a tool. This time series package, which is the ML KPI predictor, that's a tool. So all of these are tools that exist within RANGPT. So it already knows what the APIs are, it knows how data exists, so it knows how to validate the data and format the data so that it can be fed into the module or the routine that's been written by the operator. And in discussing with actual folks who do this on a day-to-day basis, most of their time is spent on just collecting data from various databases, putting it into a central place, formatting it in the right way. Should it be a matrix, or should it be rows or columns, or should it be in integer format, or what? So, and then figuring out what the sequence of APIs are and presenting data that way, right? So this is taking all of that kind of mundane work out of the purview of the expert and allowing them to focus on really solving the problem, right? That's the point here. And it's showing it's working. This is a simple tool that we wrote where it's just doing some ML KPI, like the time series prediction. That's not the point. The point is it could be a more sophisticated tool written by the operator that you could call directly using RANGPT. So that's kind of the analysis aspect of it. You could use this to control various aspects of the network. Let's say, based on this analysis and observation, you already decided to shut down the site or shut down a particular band of the site so that you can send somebody and see what's going on. You could do that directly using RANGPT. We have shown this previously in other demos. It's the same aspect that you could say shut down a particular band and it'll go and shut it down. But the thing that I want to focus on is automation, right? So let's say you've detected an anomaly, you've analyzed it, and you've managed this incident, you've taken care of this fire for now, but in the future, you want to automate this process. You don't want to be in the middle of doing the same thing again and again and again. And that's where building automations using RANGPT comes in, which is our kind of third use case that we talk about, which is the app development use case. And for that, the way we do it in the demo is that we have integrated RANGPT with VMware's non-real-time rig. So if I open that up here, the idea is you go from defining exactly what you want your automation to do to writing code, mapping that code to an RApp, and then loading that RApp into your non-real-time rig or your SMO framework. And in this case, the way we are going to show that is to do the whole flow and load it into VMware's non-real-time rig. So if I log into this, you can see already this is the gateway RApp that we talked about. It's already running on the non-real-time rig like I had mentioned previously. And then there are a couple of other RApps. The goal of this here would be to write a new RApp using just definitions, right? And for the interest of time, let's copy those definitions from here. Definition being what's the objective, what is the app that you want to write, right? So I'm saying in this case, it's a very simple if this then that kind of an RApp that I'm trying to write. The idea is observe some metrics, and if those metrics fall under certain thresholds or cross certain thresholds, then create an event, and then based on that event take an action, right? So in this case I'm saying look at the coverage band and the capacity band, look at the PRB utilization of those bands, and if the PRB utilization of the coverage band is low and there's enough headroom in the capacity, the other way around. If the PRB utilization of the capacity band is low and if there's enough headroom in the coverage band, then you could just shut down the capacity band and move all those people into the coverage band because there's enough headroom over there. So those are the three objectives here. That's exactly what this says. Observe these metrics, apply these thresholds, and if those conditions are met, then take this action, shut down this band. And it takes those objectives, maps it to code very methodically, very line by line, and it's written this code here. And the idea here is that you could do a little bit of CI/CD right here. The goal is ultimately for this code to go into your standard CI/CD pipeline, whether it's GitHub or Bitbucket, and have other teams and other folks validate it, test it, and manage it. But you could also do some initial code review directly from here, which is essentially looking at these objectives, looking at the final code. A new agent is being called and is being asked to validate whether this code that was written by RANGPT is accurate or not. But once that review is done, and let's say you want to build it, you could then build it. So let's wait for the review to happen. Yeah, it's given a bunch of results. You can go through it methodically and augment this. We are not saying that this code review is going to be comprehensive. You can augment this with your standard review process, peer review process that you have. And then let's say you are happy with this code, and let's say you want to build this, map it to an RApp and deploy it on a non-real-time rig or an SMO. All you need to do is say build and deploy. Here, the business logic that we just wrote based on these objectives is being wrapped around by a template RApp. So all the streaming data that it needs, those are being subscribed to. There are definitions and registrations. All of that template aspect of an RApp is being written, and this business logic is being inserted, and then that's when it becomes a fully built RApp. So it's saying that it's built and deployed. You can go here, take a look at this. If you refresh the non-real-time rig now, you can see that there is a new RApp that was just created today, and it's already up and running, right? So once again, the idea here is RANGPT becomes a platform that the network operators use on a day in, day out basis. to detect anomalies, to detect what's going on, see if everything is okay. If there is something off, then manage that incident, observe, analyze, test, control, and then finally wrap it by saying, automate this process so that this is automatically taken care of next time the same thing happens. So that's kind of what I wanted to talk about, Roy.
Very nice. The span of what it covers, and definitely, it is a nice evolution since the last time we spoke. I wasn't expecting the app generation and the R app with CodeGen with RANGPT. So nice indeed. Now, in terms of the use and deployment of this, how are the pilots going with the carriers? How do you see this going to market? And we know that carriers are very sensitive about new trials in their network. So, what's your experience so far?
Yes. Yeah, certainly talk about that a little bit. First things first, we've been very happy with operators' openness and eagerness to try something like this. We've been pleasantly surprised by how enthusiastically it's been welcomed. This idea of using GenAI to make things easy for the operators. So we are in the process of doing a couple of POCs, one with a large US-based operator, one with an operator out of Asia Pacific, and there are more discussions that we have been having. And in terms of sensitivities of data and so on, absolutely that is a big concern. And even though operators are eager to test new solutions and see how GenAI can help, I think it's the right thing that they're doing in terms of not kind of short-circuiting their own process in making sure that new POCs and new kind of trials and so on don't kind of hamper or worst case scenario bring down their network, right? So the way we solve it is by saying, hey, look, we can bundle in an LLM within our software. So one of the concerns has been that, hey, my data, the queries that my operator, that my network expert is writing and the responses being given, they could all become public, and we don't want that. So one of the solutions is to, again, the way we are bundling it is the LLM could become part of RANGPT itself, RANGPT solution software module. That way there's no external calls being made whatsoever, and even your queries don't get exposed. Of course, another path is some of the operators have tie-ups with various LLM private versions of LLMs. So they have already started working on, hey, how do I, if I want to use GenAI, how do I use it in a way that's within my walled garden? So if they have already done that and if they have made progress on that, so we can certainly use that. So those are a couple of different approaches we have been taking.
Thank you. So very, very impressive, Ravi. I think it's been a couple of months since we last saw RANGPT in action, and that was the inaugural demo out there. There's been a lot of progress since and a lot of cool capabilities. I think, like I said, I wasn't expecting the app generation, but that's really wonderful. And I'm pretty sure in another 4 to 5 months, when we check back again, that there's going to be a lot more advancements. So anyway, thank you for your time. I really appreciate it.
Thank you so much, Roy. Always a lot of fun talking to you. I agree, and I can't thank the operators more, because a lot of the features and the directions we are going have been because of feedback and gentle nudges that the operators have been giving us. So yeah, stay tuned. There's more coming, and we are also excited.
And that's it for this time. In a couple of months, we'll check back and see where Ravi, Aira, and RANGPT are. In the meantime, you're welcome to learn more about Aira Technologies. The website URL is here. and also AvidThink. It's just avidthink.com. Thank you again for watching and hope you've enjoyed it.